Hey there, let's cover section 2.1. Um, I find that if you go through, print your guided notes, and at this point, you can even go through the book and take your notes because it follows the book in OpenStax. And then when you come to class, you can ask any questions of something that you don't understand because you will have already seen it once. Seeing it with me in class will be a second time. And then should you want to, you could follow up with the video as well to make sure that you've got a good, strong understanding of it. So let's just get started. Cartesian coordinate system. It's a two-dimensional plane where the x-axis is the horizontal axis and the y-axis is the vertical axis. A point on the plane is defined as an ordered pair with coordinates x and y. What does it say? Such that x is determined by its horizontal distance. So if you're looking at the first value, it decides whether you're moving left or if you're moving right. And then the y value decides if you're moving up or if you're moving down. Okay. So for the x value, if the x value is negative, you're going to move left from the origin. If the x value is positive, you're going to move to the right. Okay, same thing with the y. If the y value is negative, you're going to go down. And if the y value is positive, you're going to go up. Okay, from the origin yet again. All right, so let's look at this first one. Plotting points in a rectangular coordinate system. Let's get you comfortable with this. And this is just x and y. If I can find a pen that works, hold up. And that's not a pen. All right, x and y. So -2, 4. Looking at the x-axis, it's a -2. So from the origin, we're going to go to the left. We're going to dance to the left 2 places. 1, 2. And then we're going to go up because the 4 is positive 4 places. So 1, 2, and then 1, 2, 3, 4. There is our point for that. And we need to label it. Don't just put a dot there. You always need to label what the heck it is. In class, I probably said, name your baby. So the next one is 3, 3. They're both positive. So we're going to be going to the right 3 and then going up 3. So 1, 2, 3, and then 1, 2, 3, placing your point, and then again, labeling it. And the last one is 0, -3. So 0 is in the x place. So we're not going left and we're not going right. We're either going to go in up or down. We're going to be going down in this position because it's a -3. So from on the y-axis, we're just going to come 1, 2, 3, put our point and plot. Okay. Next one is example 2, graphing an equation in 2 variables by plotting points. It says graph the equation y equals -x plus 2 by plotting the points. The other thing I'm going to tell you is please take notes. Besides taking notes, write down any questions you have as I'm going through here. If I don't answer them in the video, bring them to me and let me make sure that I answer them for you, or send me an email so I can make sure and cover it. All right. So in this case, we're given this. This is what we're given, this question right here. Graph the equation y equals -x plus 2 by plotting points. That's how they're wanting us to do this. Not by putting in y equals -x plus 2 in our calculator or on Desmos. All right. So I just randomly choose 3 points, never 2, because 2, you can still screw the pooch on that one and mess up your plot. So I always choose 3. And being that there's no fractions on this one, I'm going to choose -1, 0, and 1. So when I plug in that -1, and we're choosing points, we're choosing it for the independent variable x so that we can solve for y. So plugging in -1 for x, y will equal -1 plus 2. I'm going to keep going with this one. So y will equal +1, negative times a negative is a positive. 1 plus 2 is 3. So the ordered pair that we'll be plotting is -1, 3. The second one I chose is 0. I always choose -1, 0, and 1, again, unless there's a fraction. And then y equals -0 plus 2. Well, that's just 2. So our order pair is 0, 2. And then the last one, I chose 1. Y equals -1 plus 2. And the answer here is just 1. So the answer for our ordered pair is 1, 1. On the next page, I'm going to be plotting these. If I can do my best. -1, 3, 0, 2, and 1, 1. All right. I'm going to plot these three. And then I'm going to show you another way that I plot, just to show you. So for our first one, -1, 3, it's a negative in the x place. So we're going to shift to the left. So -1, and then the 3 is positive. So we're going up. 1, 2, 3, place point, and label it. The next one is 0, 2. So 0, we're not going left or right, and we're only going vertical. We're going up 2, placing a point. And the last one is we're going to move to the right 1 because the x value is a +1, and then we're going to go up 1 because the y value is a +1. All right, and then I'm going to do my, oh, I didn't label these. 0, 2, shame, and 1, 1. Now, I only say label the points because they have asked us to plot them. All right. But this is a line. All right. So when you have a line, the points are not the most important part. It's the actual line itself. So y equals -x plus 2. The line is your baby. And I always say, name your baby. All right. So the other way I wanted to show you is how to plot the graph without the points. Okay. I guess I should show this a little bit further down the road, but just because I've already shown it in class, I want to make sure I give it to you here as well. -x plus 2. So I start because this is representative of y equals mx plus b. And b is the y-intercept. It's where the line itself is intercepting the y-axis. And in this case, it's a +2. So from the center of the Cartesian coordinate system, I'm just going to come up 2 and place a point. I don't label it. I just place a point. Then the next thing I do is I look at my coefficient of x. And in this case, it's a -1. You can see that. But when you look at a slope, you need to have it in fractional form. And I'll show you why. If I take this -1 and make it a -1/1, it's still the same stinking thing. But when you originally learned about slope many moons ago, you learned that it's rise over run, hopefully. If not, let's talk about it now. And the negative will always go to the numerator in this case. And you will always run to the right. Okay, so the top number, the numerator in this case, is -1. So we're not going to rise -1. If we're going to rise -1, that means we're going down 1. So from the y-intercept, not the origin, from the y-intercept, we're going to come down 1 because that's the numerator. And then it has, in the denominator, run 1. So we're going to run to the right 1, place our point, and there's our line. And the last thing you do here is just name your baby. Y equals -x plus 2. All right, that's it. If you'd like to see more of that, just let me know. Pardon me. Okay. So x and y intercepts. Oh, I like these. These are fun. The intercepts of a graph are points at which the graph crosses the axis. So we're going to find the x-intercept, and that's where the graph crosses the x-axis. And then we'll find the y-intercept, and that's where the graph crosses the y-axis. So let's look at that. To find the x-intercept, I let y equal 0. So sorry. And when I do that, I'm going to go back to that the same one I had up there, which was y equals -x plus 2. I'm going to let y equal 0. And I get -x plus 2. Solving for x, adding x to both sides, I get x is equal to 2. All right. So there's my x-intercept, which is also 2, 0. All right. Right there. 2, 0. Then the other one is my y-intercept, because this one has y as 0. The next one, x is going to be 0. So for the y-intercept, we let x equal 0. So our answer is going to be 0 something. And in this case, I'm just going to have y equals negative x plus 2. I'm going to let x equal 0. And I get y equals 2 as well. Sure I'm doing this right here. Yep. Cool. So this one is 0, 2. So from here, we go from the origin up 2, because 0 is the x and 2 is the y, and that is 0, 2. Draw our line. And I'm just going to label the line because it will hurt if I don't. Okay. So we found our x-intercepts and our y-intercepts. All right. And it also has down here how you can do that. For finding the x-intercept, you just set y equal to 0, solve for x. For finding the y-intercept, you set x equal to 0 and solve for y. All right. Example 4. Finding the intercepts of a given equation. Find the intercepts of the equation y equals negative 3x minus 4, then sketch the graph using only the intercepts, just like what we did. So y equals negative 3x minus 4. To solve for the x-intercept, let y equal 0. So 0 equals negative 3x minus 4. I'm going to move the negative 3x over. So 3x equals negative 4. And divide both sides by 3. X equals negative 4 thirds, or 1 1/3, or 1.33 continuous. It's totally your call. Now for the y-intercept. For the y-intercept, we let x equal 0. Okay, so y equals negative 3 times 0 minus 4. So y equals negative 4. In this case, it's negative 4 thirds 0 is the point we're going to plot. And in the y-intercepts case, it's 0, negative 4. All right, let's plot those. 0, negative 4 does not go left or right. It just goes down 1, 2, 3, 4. Place that point, and I, again, label it. When in doubt, label. And then for the x-intercept, it's negative 4 thirds. So you're going to go to the left, 1 and basically a third. It's not going to be perfect, but that's negative 4 thirds, 0. Draw your line. Lord have mercy, I do not have a steady hand. And I always label the line. So y equals negative 3x minus 4. All right. Found the intercepts, drew the graph. Is there anything else we need to do? Nope, looks great. All right. Using the distance formula. Okay, we've been given the distance formula up here. It explains to you how they find it. It's basically a squared plus b squared equals c squared. It's the Pythagorean theorem, but solving for c. But a and b and c are all going to be given points. And in this case, we were given the points for a and b for two different, or x and y for two different points. So sorry. And so all we have to do now is solve for the distance between. All right. So let's do that. I'm going to just skip this part because I'm going to rewrite the formula for you here in just a second. All right. Find the distance between these 2 points. D equals the square root x1. Oh gosh, make it, I'm not messing this up. Yep, x2. x2 minus x1 squared plus y2 minus y sub 1 squared. All righty. Let's do plug and chug. I always label what my points are. Excuse my yellow fingers. I just had an orange a while ago and the soap didn't want to take it all off. So x1, y1, x2, y2. Now that these are labeled, I can just plug them in here to see what I get. So x2 is 2 minus a negative 3 squared plus y sub 2 is 3 minus y sub 1 is negative 1 squared. All right, so D equals, we've got 2 plus 3 is 5 squared plus 3 plus 1 is 4 squared. So D equals the square root of 25 plus 16. D equals the square root of 41. I feel like I've recorded this before. Okay, that is our distance between those 2 points, square root of 41. Now, the other thing you can do is calculate it, because who's going to go around measuring square root of 41? Well, some of us. 41, where's my square root? Oh, it's right there. Square root of 41. So 6.4 basically. So I would say D equals 6.4. We don't know what their measurements are using, inches, feet. So that kind of makes me crazy. All right, next thing. Using the midpoint formula. So here's another formula for you to make sure you have in your notes. Given 2 points, they just want to find, 2 points on a line, you can find out what the distance is, the midpoint is for those 2 points. All right, so let's do that. Find the midpoint of the line segment. Find the midpoint of the line segment with endpoints 7, -2, and 9, 5. So if the midpoint equals x1 plus x2 divided by 2, comma, because that's the x version of the point, and then we've got the y1 plus y2 divided by 2. So in this case, let's label them x1, y1, x2, y2. x1 is 7, and then plus 9 divided by 2, comma, and then -2 plus 5 divided by 2. So the midpoint is 16 divided by 2, which is 8. And -2 plus 5, which is 3 divided by 2. And there's our midpoint. You could say 1.5. Again, totally your call. It's the same thing. All right. If you have any questions, please ensure you're writing them down and we touch base before you get any further. All right. Find the center of a circle. Okay, same thing. So if I say we're going over 1 and down 4, 1, 2, 3, 4, and then we've got 5, -4. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4. There's our circle. Oh gosh. This is why I was never an artist. All right, there's my circle. We're going to find the midpoint between these 2 points. The midpoint, x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Label, midpoint, -1 plus 5 divided by 2, y1 plus y2. I'm going to write this because I had students who questioned this, and I want to make sure that you're comfortable with what we're doing here. So -1 plus 5 is 4. 4 divided by 2 is 2. -4 plus -4 is -8. -8 divided by 2 is -4. Okay. There is our midpoint, 2, -4. All right, that is it. We've got 2 more. Now, these are actually from the back of the book, from the practices, the exercises, and I thought that they were just really interesting. Give me just one moment, I'll continue. Okay, so for this one, someone drove 10 miles directly east from their home, made a left turn in an intersection, and then traveled 5 miles north to their place of work. All right, so if we think of north, south, east, and west, we say they drove 10 miles directly east. So we'll say it's 10 miles. And this was their work from their home. And then they made a left turn in an intersection and then traveled 5 miles north. So about half that. And this is their work. So if the road was made directly from the home to the place of work, as the crow flies, basically, what would its distance be to the nearest 1/10 of a mile? So we're looking for if this road actually did this. All right. Well, the intersection gave us a perfect right angle. All right. And the side of a right triangle directly across from that right angle is always the hypotenuse. It's your longest side. It's also C. So being that we have the legs of this right triangle, we can find the hypotenuse with Pythagorean. So A squared plus B squared is equal to C squared in this case. So A, we'll just say is 5 miles. B is 10 miles. Square that bad boy. And that's equal to C squared. So we have 25 miles squared plus 100 miles squared is equal to C squared. 125 miles squared, just adding them, is equal to C squared. The way to get rid of a square is a square root. So we're going to take the square root of C squared to make this just C, which what we do to one side, we're going to do to the other. Miles is going to be our unit. And the square root of 125, I don't know. Where's the calculator? So 125, and the square root is 11.2 basically. So 11.2 miles instead of 15. That sounds delightful. All right. So the next one is, if we rent a truck and pay $75 per day fee plus 20 cents for every mile we travel, write a linear equation that would express the total cost per day, Y. So we're using Y, and it looks like we're using MX plus B. B is the initial or starting value. And then the rate of change is your M, your slope. So in this case, Y equals the rate of change is the only thing that's going to affect this in regards to if numbers, the input changes, and that's the 20 cents because it's per mile. And then the original starting fee is positive 75. So there is our function. It says graph this function on your graphing calculator and find the total cost for one day if we traveled 70 miles. Well, I want to show you algebraically, and then I'm going to pull up Desmos and show you that way as well. So if we go 70 miles, we're just taking 0.2 times 70 plus 75. It's 89. 89 what? Sit-ups, push-ups, it's $89. Okay. So I'm going to pause real quick, pull up Desmos so I can show you that as well. Okay. Oh, let me move this real quick. So here's our line. All we have to do is come up here and find the 70, because we were talking about 70, and looks like, oh, let me just come down here a little bit. 70 right there. And it looks like our answer is 89. Yep, it came up as 89. Perfect. So that's how we find it in there as well. If you don't know how to use Desmos, let me show you how that looks. So if you go to desmos.com, I just use the graphing calculator. So if you don't have a graphing calculator at home, you can use this. It's delightful. And you can just go up here and type. It's very easy to use. We're going to use it a lot going into transformations. All right, that's it for this one. I will get this out to you today, and I hope you have a great day.